The National Electrical Code, or NEC, restricts the use of aluminum conductors in certain residential wiring applications. Specifically, NEC Section 250.148b addresses conductors in buildings. According to the 2017 NEC, aluminum conductors are not permitted for branch circuits supplying 15 or 20 amp receptacle outlets. The 2020 NEC expands on this restriction. It states that aluminum conductors shall not be utilized for branch circuits supplying 15 or 20 amp receptacle outlets or for feeders supplying branch circuits that supply 15 or 20 amp receptacle outlets. Therefore, understanding the distinction between branch circuits and feeders is crucial when interpreting these code requirements. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. A feeder, on the other hand, is all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source, and the final branch circuit of a current device. In simpler terms, feeders supply power to branch circuits, which then directly supply power to outlets and devices. The NEC restriction on aluminum wiring in residential settings is primarily focused on these specific types of circuits due to concerns related to the properties of aluminum and its potential behavior under certain conditions. Aluminum has a higher coefficient of thermal expansion compared to copper, meaning it expands and contracts more with temperature changes. Over time, this expansion and contraction can lead to loosening of connections at terminals, potentially causing increased resistance and overheating. Another factor is the formation of aluminum oxide on the surface of aluminum conductors. Aluminum oxide is an insulator which can also increase resistance at connections. To mitigate these risks, when aluminum conductors are permitted, special connectors and installation techniques are required. These include using connectors that are specifically designed and listed for use with aluminum conductors and applying an oxide-inhibiting compound to the conductor before making the connection. These practices help to ensure a secure and reliable connection that minimizes the risk of loosening or corrosion. It is important to note that the NEC restrictions on aluminum wiring are not a blanket prohibition. Aluminum conductors are still permitted in many other applications, such as service entrance conductors, feeders supplying larger loads, and in certain types of equipment. The key is to understand the specific requirements of the NEC and to follow the manufacturer's instructions for the proper installation and termination of aluminum conductors. It is also essential to consult with the local authority having jurisdiction, or OJ, to determine their specific requirements and interpretations of the NEC. As the question pointed out, the AHJ in some areas do not allow aluminum on the load side of the meter base, while others do. This highlights the importance of understanding the local regulations and ensuring that all electrical installations comply with those requirements. In summary, the NEC restricts the use of aluminum conductors for branch circuits supplying 15 or 20 amp receptacle outlets. The 2020 NEC also includes feeders supplying these types of branch circuits. This restriction is primarily due to concerns about the expansion and contraction of aluminum and the formation of aluminum oxide, which can lead to loose connections and overheating. When aluminum conductors are permitted, special connectors and installation techniques are required. Always consult the NEC and the local AHJ to ensure compliance with all applicable regulations. Aluminum conductors are generally allowed for service entrance conductors because these connections are usually robustly designed and properly torqued. Furthermore, regular maintenance helps to ensure safe operation. The prohibition described in NEC Section 250.148b applies to aluminum conductors used in branch circuits that feed small appliance circuits or general lighting circuits rated at 15 or 20 amps. These smaller circuits, serving devices like lamps, toasters, and other small appliances, are more susceptible to issues arising from aluminum's properties. When dealing with heavier-duty applications such as feeding an entire subpole or large appliance, the larger gauge aluminum wiring and appropriately rated connectors can be employed safely, provided they adhere to stringent installation practices and regular maintenance protocols. When using aluminum wiring, it's vital to select connectors and terminals that are specifically rated for use with aluminum conductors. These connectors are typically marked with the designation ALCU, signifying their compatibility with both aluminum and copper wiring. Using improper connectors can lead to galvanic corrosion, a process where one metal corrodes preferentially when in contact with a dissimilar metal in the presence of an electrolyte, such as moisture. Proper wire sizing is another critical aspect of using aluminum wiring. Because aluminum has a higher resistance than copper, it's necessary to use a larger gauge aluminum wire to carry the same amount of current as a copper wire. The NEC provides tables that specify the appropriate wire sizes for different ampacities, taking into account the conductor material and insulation type. For example, a circuit requiring a 12-gauge copper wire might necessitate a 10-gauge aluminum wire. Torquing connections to the manufacturer's specifications is equally important. Over or under tightening can both lead to connection failures. Over tightening can damage the wire or connector, while under tightening can result in a loose connection. A calibrated torque wrench should be used to ensure that all connections are properly tightened. Applying an antioxidant compound to aluminum conductors before making connections is another best practice. These compounds help to prevent the formation of aluminum oxide, which, as mentioned earlier, is an insulator and can increase resistance at connections. The antioxidant compound should be applied to the cleaned conductor surface and then the connection should be made immediately. Regular inspections of aluminum wiring connections are crucial for identifying and addressing any potential problems early on. Connections should be checked for signs of loosening, corrosion, or overheating. If any issues are found, the connection should be retorqued or replaced as necessary. Aluminum wiring can be a safe and cost-effective alternative to copper wiring when installed and maintained properly. However, it's essential to understand the unique properties of aluminum and to follow the NEC guidelines and manufacturer's instructions to ensure a safe and reliable electrical system.